So this is module 2, lesson 3, which is states of matter. So we've talked about matter, we talked about what that is, and how it combines. So now this is just leading into the different types of states. So a chemical reaction is when something changes from one state to another or a different substance. So we could have hydrogen and oxygen, which are both gases. They combine to form water, which could be a solid, liquid, or gas. So there's two different ways that solids are packed. And so this is showing in this diagram a crystalline structure. So a crystalline structure is where everything's nice and neatly arranged. And then we have amorphous structure, which is like glass. So glass is a solid, but they are not arranged in a crystalline pattern. The atoms are just kind of there. Stuck together. So it's not any particular pattern. When we look at minerals, minerals all have a definite crystalline structure. So glass could never be a mineral. Even if it's naturally occurring, like on a beach or something like that, it's not going to be a mineral because it doesn't have a crystalline structure, it doesn't have a definite structure like this is here. And then we have liquids. So liquids, basically, if we increase the temperature of a solid, it's going to turn into a liquid. And liquid, the molecules, the atoms can move around. They're not free to move wherever, like in a gas, but they can slide past each other. They're always in contact with each other, but they are able to move around freely. So there is no crystalline structure. And obviously, a great example would be water. Gases are they're the next state, and they can move everywhere. So they don't necessarily have to be touching each other like a liquid. They definitely are freely moving. They're moving much more so than liquid, and then definitely more so than solid. So a great example here is CO2. If something goes from a liquid to a gas, it has to reach what's called the evaporation point. So it goes from, think about water. Water evaporates at 100 degrees Celsius or 212 degrees Fahrenheit. So it goes from a liquid to a gas at that state. Just like if you go from a solid to a liquid, you have to reach the melting point. So here you have to reach the rate of evaporation. All right, and then the next state, this is basically a gas. So plasma is a gas, but it's charged. And so lightning is a good example. Fire is a good example. So anything that's ionized, meaning that it has a charge, would be plasma. So you can see in this ball that you put your hand on that you have this charged gas that's in it. Neon lights are a great example of plasma as well. So anything that is charged. All right, and so all of these things can go, well, not everything, but if we talk about water, water can go through all of these different states, and lots of other things can happen. So in order to do that, it has to reach certain points. It has to reach freezing point to go from a liquid to a solid. It has to reach the melting point to go from a solid to a liquid. It has to reach vaporization point, which, like I said, for water is 100 degrees. Every element or every compound is different. So just because water melts or evaporates at 100 degrees doesn't mean 100 degrees Celsius. It doesn't mean that everything does that. So some things are liquid at room temperature. Some things are solid at room temperature. So it just depends on its melting point and its evaporation point, as well as its, which is called the vaporization. Or, just depends on what it's doing. So if we look at changes of state, we've got going from a solid to a gas is called sublimation, and going from a gas to a solid is called deposition. So taking a look at these, we can see, like I said, condensation or sublimation is going from solid to a gas, and then going from a gas to a solid is deposition. So these are terms that you guys might not know. And then if we look at going from a solid, a liquid to a gas, those are the terms that you probably know. So melting, is going from a solid to a liquid, and freezing is going from a liquid to a solid. Boiling, condensation, these are generally terms that you already know. The only two that you might not know, sublimation. So a great example of this is dry ice. So that's basically solid CO2. And that goes straight to a gas. Sometimes water can do this, like on the windshield, you'll have ice particles and then the sun will hit it and you'll see steam come off. So that is going straight from a solid to a gas. And that's just because it's a very thin layer. And it's really not having time to go to the liquid phase. And then deposition, going from a gas to a solid, could also be fog, for example. If it gets cold enough, fog can freeze and form ice on a windshield. So that could be the same thing. All right, and then if we look at conservation of energy, it's known as, one of the laws is known as the first law of thermodynamics, which I'll talk about now. And that's like when we balance the chemical equations. I said that matter is never created or destroyed. So that is the first law of thermodynamics. We can go from one state to another, or we can change things from one compound to another, but they can't disappear, or they can't be magically created. We can't take something and have the elements disappear, or just make something out of air, out of nothing. So we have to, everything is converted. So there's a finite amount of elements present on Earth, and so they're just constantly recycled back and forth, and that's the whole basis of the first law. And that's it. Hope you enjoyed.